Good evening, one and all. Welcome back to live discussion session for the NPTEL course Soil Mechanics Geotechnical Engineering I. I am Reshma R, research scholar from Department of Civil Engineering, IIT Madras. So, I hope all of you have gone through the lecture videos of the last week. So, let's move on to the discussion session. I'll share my screen now. I hope my screen is visible to everyone. All right. So, first question for today's discussion is a soil sample having a void ratio of 1.596, water content of 60%, and a specific gravity of 2.67 is in a state of option A, partial saturation, option B, full saturation, option C, oversaturation, option D, undersaturation. So, we are given a soil sample and we know the values of void ratio, water content, and specific gravity. We need to identify the state of soil sample with respect to the saturation level. So, which parameter do we need to estimate for solving this question? Yes, it's degree of saturation. So, can you all please calculate the degree of saturation for this particular soil sample and let me know the correct option? Yes, the correct option is full saturation. So let's see how to solve this. We are given with void ratio 1.596, water content as 60%, specific gravity as 2.67. We know a equation relating void ratio, degree of saturation, water content and specific gravity as ES is equal to GW. Right. Where all the parameters except S is known. So, substituting all those values, we will get degree of saturation S is equal to GW by E. That is 2.67 into zero point 0.6 by 1.596. We are substituting, we need to substitute the water content in decimal value. So, we will get the degree of saturation as 1.004, which is approximately 1. That means whole of the voids in the soil mass is filled with water. That means degree of saturation is equal to 1. What is the equation for degree of saturation? It is volume of water by volume of voids. So here volume of water is equal to volume of voids, right? So that means our soil is fully saturated. So at least some of you might have thought it is greater than 1, like what is 1.004. So it is some very, like it's a bit greater than 1. Then why not oversaturated? So when it comes to soil mass, depending upon the degree of saturation, we term it as partially saturated and fully saturated, depending upon whether the voids have air or not. So if the soil mass contains void spaces that is partially filled with air and partially with water, we term them as partially saturated soil. And if those voids are completely filled with water, it is fully saturated soil. And if the voids are completely filled with air, it is dry soil. So, if we have to say like degree of saturation greater than 1, then what is the condition? Mathematically, VW becomes greater than volume of voids, right? So that we are not considering. We are concerned about the water that is present within the voids. So the particular soil given here is fully saturated. Going to the next question. The porosity and the degree of saturation of a soil sample are zero point 0.8 and 40 percentage respectively. In a 100 meter cube volume of the soil, the volume of voids in cubic meter is. So, here we are given the porosity N and degree of saturation S of a soil sample. Also, the total volume of the soil sample is given. We are asked to determine the volume of voids. Can anyone tell me which relation we should use here, which equation we should use here? Yes, porosity is defined as the ratio of volume of voids to the total volume of the soil sample. So, here porosity is known, total volume is known, we can determine volume of voids. Let's see how. So, we are given porosity, degree of saturation and volume of soil. We know that porosity is equal to volume of voids by total volume. Rearranging the equation for volume of voids VV, we get it as VV is equal to NV, that is 0.8 into 100. So, we get the total volume of voids as 80 meter cube. I'll pause here for a minute so that all of you can note this down, and then we'll move on to the next question. It's just a simple substitution from the basic equation for porosity. Okay, so here is the next question. The porosity and the degree of saturation of a soil sample are zero point 0.8 and 40 percentage respectively. In a 100 meter cube volume of the soil, the volume of air in cubic meter is. So, the data given in the question is same as that of the previous question. The parameter we need to calculate is volume of air. Earlier, we have already calculated volume of voids. So, for the first question, I told you that inside the soil mass, within the soil mass, there will be soil solids as well as voids or empty spaces. These empty spaces may be either filled with air or water or a combination of both. So here, in the previous question, we determined the volume of these voids or empty spaces. Now, in this question, they are asking us to determine the volume of air that is there in these voids. Let's see how to solve that. So, as in the previous problem, we are given porosity N as 0.8, degree of saturation S as 40%, volume of soil V as 100 meter cube. So, as in the previous problem, porosity is equal to VV by V and hence volume of voids is equal to 80 meter cube. I hope everyone have understood till this. So, now if we consider a three-phase soil sample diagram, three-phase diagram of the soil sample, that is with a soil sample with voids that is partially filled with air and partially with water. So, we can say that the total volume is composed of volume of voids and volume of solids. Again, this volume of voids is a summation of volume of air and volume of water. So we know the volume of voids. What is the value of volume of voids? We know it is 80 meter cube. Then if we know volume of water, we can determine volume of air, right? Now, in the question we are given degree of saturation. What is degree of saturation? It is the ratio of volume of water to the volume of voids. Volume of water to the volume of voids expressed as percentage, that is degree of saturation. We know the volume of voids, that is 80 meter cube. We know degree of saturation 40%. Substituting in this equation, we'll get volume of water as S into 80 by 100. That is 40 into 80 by 100. This 100 comes in here in this equation because S is in percentage. If S was in decimals, this 100 is not required. Alright, so volume of water, we got it as 32 meter cube. Now, we know the total volume, we know the volume of water. Just deduct, we'll get volume of air. Okay, 1 second, let me pause here. Okay, we'll come back. So, we have the next question. So, we have to obtain the volume of air, that is by deducting volume of water from the total volume of voids. So, we get it as 48 meter cube. Is that clear? I'll pause here. Please note this down and then we'll go on to the next question. Okay, here is our fourth question. A 50% saturated soil sample has a natural moisture content of 10% and specific gravity of solids is 2.67. Assume unit weight of water as 9.81 kilonewton per meter cube. The dry unit weight gamma D, bulk unit weight gamma B, saturated unit weight gamma sat and submerged unit weight gamma sub of the soil in kilonewton per meter cube are. So, here we are given the degree of saturation of the soil sample, natural moisture content of the soil sample, specific gravity of solids as well as unit weight of water. We are asked to determine 4 different unit weights: bulk unit weight, dry unit weight, submerged unit weight and saturated unit weight. So let's see how to solve this. So we are given degree of saturation as 50% or 0.5, natural water content as 10% or 0.1, specific gravity as 2.67, unit weight of water as 9.81 kilonewton per meter cube. We need to determine 4 different unit weights. First, we will note down the equation for each of them. Alright, so the equation for bulk unit weight gamma B is equal to G gamma W into 1 plus W by 1 plus E. Bulk unit weight gamma B is equal to G gamma W into 1 plus W by 1 plus E. Now, when the soil sample becomes dry, we have dry unit weight. That means water content W is 0. So, this equation becomes gamma D is equal to G gamma W by 1 plus E. Gamma D, dry unit weight, is equal to G gamma W by 1 plus E. Alright, now saturated unit weight gamma sat is equal to G plus E into gamma W by 1 plus E. Then last one, gamma submerged, is equal to gamma saturated minus unit weight of water. So, when we look into these 4 equations, the only unknown here is void ratio. All the other terms, that is specific gravity, water content, unit weight of water, all these values are given. So, all the values except E are given. But in the previous problems we saw, we have a relation between void ratio, specific gravity, water content and degree of saturation, that is ES is equal to GW. So, E we can get it as GW by S. That is 2.67 into zero point 0.1 by zero point 0.5, which is 0.534. So we get void ratio as 0.534. Now to solve this problem, it's simple substitution in these four equations for unit weights. So first we have bulk unit weight gamma B, which is equal to G gamma W into 1 plus W by 1 plus E. Substituting for all the values, we get it as 18.78 kilonewton per meter cube. So the unit basically comes from the unit weight of water. So here we are substituting it in kilonewton per meter cube. So answer we will get in kilonewton per meter cube. Okay, so gamma D is equal to G gamma W by 1 plus E. That is equal to 17.075 kilonewton per meter cube. Okay, so now what is gamma saturated? It is G plus E into gamma W by 1 plus E. That is 20.49 kilonewton per meter cube. Now the last one, gamma submerged, which is equal to saturated unit weight minus unit weight of water, which is equal to 20.49 minus 9.81, which gives you 10.68. All right. So let's move on to the next question. I hope it's clear till this point. All right. So the next question. Soil is to be excavated from a borrow pit to make an embankment of 50 cubic meter. Unit weight of undisturbed soil in moist condition at pit is 16 kilonewton per meter cube and natural water content is 8%. The dry unit weight required in the embankment is 18 kilonewton per meter cube with water content 8% itself. Now the specific gravity of soil solids is 2.6 and unit weight of water is 9.81 kilonewton per meter cube. Find the volume required to be excavated from the pit to construct the embankment in cubic meter. Second question, find the degree of saturation of the embankment soil in percentage. And third question, saturated unit weight of the embankment if embankment is fully saturated. So, let's see what is there in the question. We are going to make an embankment of volume 50 cubic meters. Embankment means a heap of soil or a like piled up structure, right? Soil piled up structure. So, we are going to make an embankment. We know the total volume required for the embankment is 50 cubic meters. So, for that, we are excavating soil from a borrow pit. We are given that the unit weight of undisturbed soil in moist condition is 16 kilonewton per meter cube. So, what kind of unit weight is it? Is it dry unit weight, bulk unit weight, saturated unit weight, or submerged unit weight? Yes, it is bulk unit weight because it is the unit weight of undisturbed soil mass in its natural moisture condition. So that is bulk unit weight. So bulk unit weight of the soil in the pit is given as 16 kilonewton per meter cube. Then natural water content is given as 8% or 0.08. Then for the embankment, dry unit weight required is 18 kilonewton per meter cube. So gamma D embankment is 18. Again, water content is there also 8% or 0.08. Specific gravity of soil solids G is 2.6 and gamma W, unit weight of water, is 9.81. So we are given with 4 options. Let's see which option is correct. Okay. So we are given with the required volume of embankment as 50 meter cube. Required volume of embankment is 50 meter cube. Natural water content is 8% or 0.08. Specific gravity G is 2.6. Bulk unit weight of soil in pit is 16 kilonewton per meter cube. And dry unit weight required in embankment is 18 kilonewton per meter cube. Also, unit weight of water is given as 9.81 kilonewton per meter cube. So, we need to determine the volume of the soil that is to be excavated from the pit. So, the basic concept behind solving this problem is the volume of soil solids that we are excavating from the pit is equal to the volume of the soil solids that will come up in the embankment. Once again, I'll repeat. The volume of soil solids or simply solids that we are excavating from the pit will be same as the volume of soil solids that will be coming up in the embankment. So we know that the required volume of the embankment is 50 meter cube, but that is the required total volume. The concept I have told is the volume of soil solids that is coming from the pit is equal to volume of soil solids in the embankment. We know that volume of soil solids is equal to total volume of soil minus volume of voids. Earlier in the three-phase diagram we saw total volume means it is summation of volume of solids and volume of voids. So to obtain volume of solids, we need to deduct volume of voids from total volume. Right. Now, from the relation for or equation for void ratio, we know that void ratio is equal to VV by Vs. So VV becomes, or volume of voids becomes, void ratio into volume of solids. Substituting that value for VV here in equation for volume of solids, we will get Vs is equal to V minus Vs into E. Taking all the Vs to one side, we get volume of solids Vs is equal to V by 1 plus E. Right? Okay. So we got Vs is equal to V by 1 plus E. And we know that this Vs is same for pit as well as embankment. That means V embankment by 1 plus E embankment is equal to V pit by 1 plus E pit. The total volume in the pit, that is the total volume excavated from the pit, may not be same as the total volume in the embankment because the void ratio may differ depending upon the compaction and other factors, but the volume of solids will remain constant. So, now in this equation, we already know V embankment, that is V embankment is equal to 50 meter cube. Now we need to determine the void ratio of embankment and void ratio of pit. But we are given the dry unit weight and bulk unit weight of the embankment and pit, right? So, if we analyze these two equations, we will get to know that all the parameters except void ratio is given in the problem. Okay, so by substituting for void ratio of pit and void ratio of embankment, we will get it as E pit is equal to Which equation should we use? This one, because they have given bulk unit weight for the soil in the pit. Substituting for E, we get E is equal to G gamma W by into 1 plus W by gamma B minus 1. Let us take this 1 plus E denominator to this side, bring this gamma B to the right hand side of the equation, and then this remaining one here, deduct that. So we get void ratio of pit as 0.722. In a similar manner, since the dry unit weight of embankment is given, taking this equation, gamma D is equal to G gamma W by 1 plus E, we get E embankment as 0.417. So back substituting in the volume equation, we will get volume of the pit or volume of the soil to be excavated from the pit is equal to 50 by 1 plus 0.417 into 1 plus 0.722. That is volume of embankment by 1 plus E embankment into 1 plus E pit, which is equal to 60.762 meter cube. That is, we need to excavate a total volume of 60.762 meter cube in order to make an embankment of 50 meter cube. Okay, so that was the first part of the question. What was the second part? It was to determine degree of saturation. So we know all the values. So we now need to determine degree of saturation in the embankment. We know the equation ES is equal to GW. We have been using this in all the previous questions, right? So here for the embankment, we need to take E embankment. So degree of saturation in the embankment is equal to GW by E embankment. So that is 2.6 into 0.08 by 0.417. We will get it as 0.4988 in decimals or 49.88 percentage. So the degree of saturation in embankment is 49.88 percentage. All right. Okay, so the last part of this problem was if the embankment is fully saturated. If the embankment is fully saturated, then what is the saturated unit weight? So, when the embankment is fully saturated, we know that S is equal to 100% or 1. And we know that saturated unit weight equation is G plus E into gamma W by 1 plus E. So, all the terms are known. By substituting 2.6 plus 0.417 into 9.81 divided by 1 plus 0.417, which gives you 20.88 kilonewton per meter cube as saturated unit weight. All right. So I hope this question is clear for you. The basic concept was the volume of soil solids that is excavated from the pit will be equal to the volume of soil solids that is there in the embankment. Okay, we'll move on to last question for today. That is, a stratified soil deposit is shown in figure below along with the coefficients of permeability of individual strata. Stratified soil deposit is nothing but a soil with layers, like different layers, each layer having a particular property. Here, for each layer, we are given their individual coefficients of permeability. And we are asked to determine the average coefficient of permeability for horizontal flow. So, in this soil strata, flow can either be in this direction, that is in the vertical direction, perpendicular to the soil strata, or in the horizontal direction, that is parallel to the soil strata. So, we are given with the depth of each soil strata as well as the coefficient of permeability of each soil strata. So how to determine? So we are given that the coefficient of permeability is 4.9 to 10 raised to minus 4 centimeter per second for the first 2.5 meter. So in order to substitute in the equations, we need these two parameters, the depth and coefficient of permeability, in the same units. That means here it is centimeter per second, means the depth also should be in centimeter. Or we should convert this coefficient of permeability to meter per second. But since in the question we are asked to determine the coefficient of permeability, average coefficient of permeability in centimeter per second, we will convert everything to centimeters. Now, we have two equations for average coefficient of permeability. One when the flow is perpendicular to soil strata and one when the flow is parallel to soil strata. When the flow is perpendicular to soil strata, average coefficient of permeability in the vertical direction Kv is equal to sigma I equal to 1 to n Hi by sigma I equal to 1 to n Hi by Ki, where H denotes the depth of the soil strata, K is the coefficient of permeability of that particular soil strata, n is the number of strata. N is number of strata, H is depth of soil strata, K is coefficient of permeability of soil strata. Now when the flow is parallel to soil strata or horizontal, average coefficient of permeability Kh is equal to sigma I equal to 1 to n Ki Hi by sigma I equal to 1 to n Hi. So here in this question, we are asked to determine the average coefficient of permeability when the flow is horizontal. That is when the flow is parallel to soil strata. So we will use this second equation. So substituting, we have H1 K1 plus H2 K2 plus H3 K3 divided by H1 plus H2 plus H3, which will give you 0.0118 centimeter per second, that is option A. So with this, questions are done. So if you have any other doubts, we can clear that off, or else we can stop the session for today. Okay, I'll stop my screen sharing. All right. So I hope it's clear. So we'll meet for the next live discussion session on next Monday, 6 p.m. Thank you all.